We're going to talk about some drills that we have in the shop. The first one is an electric drill. This one plugs in, it's got plenty of power, so we want to use it to drill holes with any kind of bit that will fit in there. We've got a 3/8 inch chuck, so we can fit anything with a 3/8 inch diameter or smaller into our chuck. The other drill that we have is our cordless drill. This one we typically use for driving in screws, mostly because the advantage of the cordless drill over the electric drill is that it has a clutch. So the clutch is what applies a certain amount of torque to the screws that you're driving in. Yes, you can use it for drilling holes if absolutely necessary, but we try to reserve these for just driving in screws, so they're available. So when I talk about the clutch, you can usually hear it engaging when you're trying to apply a lot of torque to a screw. So if I pull the trigger, you can hear that clicking. That clicking means it's not trying to drive the screw in farther. So that's the advantage of the cordless over the electric. It has a clutch. So let's take a closer look at the electric drill to get started. All right, with the electric drill, there's only a couple things you need to worry about. One is putting a bit in. I'll show you that in a second. The other is the direction that it turns. So over next to the trigger, there is this little switch. You can see an arrow that's printed onto the drill, and the arrow is pointed this way. So when the switch is closest to that arrow, it will drive a screw or drill in a forward direction. If you're trying to remove something, you can put it in reverse. The other is the trigger. So all of our triggers on any drill, you can change the speed at which the drill turns just by how much you squeeze the trigger. Okay, a little squeeze will turn slow, more of a squeeze will turn faster. Then, for inserting a bit, if I look at my chuck, there are two little halves to this chuck. You can see kind of the parting line right here. And they have a knurled finish on them to make it easier for you to grab on and twist them. So there's a couple different ways that you can put a bit in. One is I just put in the bit, and I don't have it plugged in right now. And I'm going to turn the top half of my chuck and hold the bottom half tight until I hear it start clicking. There. Okay, so I heard a few clicks happen. So if I grab the bit, now the drill doesn't fall off the bit. It should be in there pretty secure. Okay. The other thing that you could do once you get used to putting bits in and out is actually do it when it's plugged in. So if you do this when it's plugged in, you need to be very careful that you do not put your hands anywhere near the drill bit, otherwise you could get cut from the drill bit. So right now I've got a drill bit that is secured in here, so to release it I'm going to put it in reverse. Then I'm going to hold on to that top half of the chuck really, really tight. And then I'm going to lightly pull the trigger until that chuck opens up. And then my bit is loose and it pulls right out. To put it in, I'm going to put the bit in the chuck. Now I'm going to flip the switch to forward, hold on to the chuck tight just like before, and then squeeze the trigger very lightly. And then you should hear those clicks again. And now my bit should be secure in the drill. Okay, so there's a couple different ways that you can insert and take out bits. I'm going to start by drilling a hole. So whenever we're drilling a hole through any kind of material, we want to have a backing board. So I've got a clean backing board. Yes, there are some holes drilled, but I'm going to use a part of the backing board that hasn't been touched yet. I got a couple pieces of material that I'm going to join together with screws eventually. Okay, but right now I've just got a large bit in my drill, so I'm just going to drill a hole with this one. Now, whenever we're drilling holes, I've got everything secured. With clamps, I'm going to drill all the way through this one, so I've got my backing board. Whenever we're using a drill, we can put both hands on the drill itself. If you got it secured with clamps, you don't have to worry about holding on to the material. This makes it easier to put more downward force. So I've got my drill in forward right now. It's always going to stay in forward, even when I'm backing the drill bit out of the hole. So I'm going to drill this hole. Now to get the bit out, I keep it in forward and I just pull the trigger and pull it out. Okay, so you never have to put this in reverse unless you need to like remove a screw. Okay, so there's a nice clean hole. Now for the other drill, I've got my cordless drill. So again, this one is intended to drive in screws. If all of those electric drills are being used, you can use this to drill a hole. So that's what I'll do. So let's set up two pieces of material. So I got my two pieces of material that I'm going to join together with the screw. So in this case, what I want to do is drill a pilot hole first. I'm going to countersink it, and then I can drive in my screw. So I'm going to secure the two pieces. Now I'm going to use an 1/8 inch drill bit for a pilot hole. This is a pretty general size. It works with most of the screws that we have. So I am going to put my drill bit into the drill. Again, it works the same way as the electric drill. I can loosen and tighten the chuck just by hand if I'm not comfortable having it on while I loosen and tighten the chuck to put in a bit. So now, for settings, if I'm going to drill a hole, I have to look at a couple of the settings on here, and there's quite a bit. So the first thing I'm going to do, since I'm using a drill bit, I'm going to put it in second gear, and then on this application selector, this black ring, it should match what you're doing. So there's two pictures, one is a screw, one is a drill bit. I'm drilling, so I'm going to put it on drill bit, and then when it's on drill bit, it disengages the clutch. So I do not have to worry about this other black ring with all the numbers up to 18 on it. You don't have to adjust that. Just make sure it's in second gear and it's on the drill bit application. So I've got my 1/8 inch drill bit. Now just like before, I don't have to really worry about a 4-inch safety clearance because both my hands are on the drill itself. So now I'm going to drill my pilot hole all the way in and out. If you have problems drilling a hole and it's not really going down anymore, what you can do is kind of back it out, clear some of that sawdust out, and then plunge again. And you can keep doing that until you're all the way to your full depth. Okay, so I just drilled a pilot hole. Now I want to drill a countersink hole. So a countersink hole and my countersink bit is going to fit the head of a screw. So if I look at my screws, okay, they're flat on top and they're kind of cone-shaped underneath. So I want to make a cone-shaped hole, and that's what the countersink bit is going to do. So just like any drill bit, again, it's in second gear and the application selector is on the drill bit. So now I can just drill lightly a hole big enough to fit the screw head. If I'm not sure if it's deep enough, what I can do is take the screw itself, I got it upside down, and now I can see if the head of the screw fits in there, and it does. So I need to switch over the bit to a drive bit. So I'm going to take my countersink bit out, switch it over to my square drive bit. Now I need to change the settings. For driving in screws, we're going to switch our speed to 1, and the application selector, I'm going to change that over to the screw option. And now for the clutch, since it's engaged, you want to use a low setting for any soft materials or thin materials. Okay? Since I've got a soft material and it's kind of thicker, I got to use a longer screw. For this one, I got to use a 2.5 inch screw. I might want a little more. So whenever you're going into harder materials that need to go deeper, you want to use a higher number on your clutch. Okay, so for this one, I'm going to go kind of in between. I'm going to use about maybe a 10. We'll try that. So that's kind of a happy medium. It's always best to set it low. That way, you can always set it higher and drive the screw in deeper. If you've got the clutch set really high, you can drive the screw all the way through. Okay, so that's what you're trying to avoid. You want the screw kind of flush with the top face. So I've got my screw. I'm going to put it in my pilot hole. And just like before, I'm going to put a lot of downward pressure. That's really key when you're driving in screws because that keeps the drive bit tight into the head of the screw. If you don't put a lot of downward pressure, that bit can start skipping, and then what it'll do is it will strip out the head of the screw. So then you won't be able to drive it in farther, and you probably won't be able to drive it back out either. Okay, so you always want to have tons of downward pressure whenever you're driving in screws or removing a screw. So I'm going to drive this one in. When I drive it in, I don't have to put full speed on the trigger. Okay, if you go full speed with the trigger, again, you lose kind of control when you get the screw in farther. You don't want it driving in too far, so take it easy. So there you go. You heard the clutch engage and it stopped driving the screw in. So that was a pretty good setting for this length of screw and this kind of material. It's kind of trial and error, so play around with it, and like I said, always start low with the clutch if you're not sure. All right, now I need to back this screw back out. So on this drill, your direction, again, is right behind the trigger. Just push these buttons back and forth. Okay, so now I've got it in reverse. Just like before, I'm going to put a lot of downward pressure. Even with a couple 100 pounds of downward pressure, that screw will still lift out of there. And that's just what you want, so you don't strip out the head of the screw. So there it is. There's our 2 drills.